So, as we are already in this trigonometric part, with trigonometry, when graphing these trigonometric functions, you have to be very careful because there's a lot of transformations to it. You guys are going to see that there's transformations, reflections, and so on when we're talking about these trigonometric functions, right? But the thing is, remember that all of these contents are building up to the final image, in which we're going to be discussing and telling and investigating what is actually the basis of engineering and why these graphs are actually important. So that's what we're investigating throughout all these videos. Remember that, it's in the description. All right, so today let's do more transformations of both sine and cosine, as I gave a preview of them. So if we have y equals sine of x, let's do pi, no, let's do 4x minus pi, right? See that we have this graph right here, right? And let's always put the general formula here. Y equals a sine of bx minus c, brackets plus d, right? Okay, so what is the first thing, as we always say? Remember, amplitude. So we have the absolute value of 1, which equals 1, right? Which is the absolute value of a. So the second thing that we do is the period, in which we know that's 2 pi over b. In this case, b is 4, so that equals 2 pi divided by 4, which once again equals pi halves. As most of the videos that we saw already, the period is always being pi halves, right? So 3, we have the x scale, in which the x scale is just your period divided by 4, so we multiply by the reciprocal. Divided by, this is a 2, by the way. This is, so we multiply by the reciprocal. It cancels out. So you have pi 8, and then you go to your phase shift. So you go to your phase shift, in which is your bx minus c equals 0, right? If you wanna find the start, but if you find the end, it's bx minus c equals 2 pi, right? In which we can do this. We don't actually have to do this in this case, right? But if you want to find your end of your first period, here it is. And one thing, guys, I'm gonna be showing you guys other transformations in the next video, right? This is just specifically for sine. The other one is gonna be for cosine, right? And then we're getting to tangents. So what we do now is we can say that 4x minus pi equals 0. And how do we solve a linear equation? We add pi to both sides. This cancels out. We add the pi. So we know that 4x equals pi. What do? We divide 4 on both sides. Cancels out. And our phase shift, or our new starting point, is pi fourths. Right? This is our new point, pi fourths. And last thing we see is d, but we see that it's none, right? None. Right? So we don't have to worry about d. But now let's actually get to the graph. So I'm just going to delete all of this here. I want to leave some space to do the actual graph. I'm going to make this amplitude a little bit smaller. Right? Let's do here. Absolute value of a equals absolute value of 1. Okay, so let's remember, we only have to do a fourth coordinate plane when we have negatives. In this case, once again, we don't have a negative. In our next video, for sure, we're going to have negative numbers, right? Both up and, well, we always have down, right, because of the amplitude. But we're going to have to the reflection of our y-axis, because we're going to have sine reflecting over the y, not over the x-axis is very difficult, but we can do one example over the x-axis, and we're going to do multiple examples over this y-axis, right? But first, let's start with this transformation to make sure that you guys truly understood our last video, because I really want to enforce this. It's tricky. So now our amplitude is down -1 and up 1, where we saw that our starting point right here is now pi fourths. We saw that our I scale is pi eighths, And just like we're dealing with fractions, right, we have to do pi fourths plus pi eighths. And this is why I chose example with, so you guys know how to deal with multiple variations before we get to extra transformations. So we multiply 2 to make common denominators, plus pi eighths, that equals 3 pi eighths. So we have here 3 pi eighths, 3 pi eighths, right? And then we do 3 pi eighths plus, we do 3 pi eighths plus, we have figured this part already, plus 2 plus pi eighths, sorry, plus pi eighths, which equals 4 pi eighths. This is 4 pi eighths, right? And this is our start, so we need a few more points. Let me just delete this here. And then we know this is 5 pi eighths, right? And remember 1, 2, 3, 4, and we always need that 1 here. So we have, let me make it bigger. So we have 6 pi eighths. And one thing, guys, remember to always do 2 periods. In this case, I'm not doing because of space. But in the next video, I'm gonna try to do one with at least 2 periods, so you guys can, you know, get to that rhythm of the IGCSE, and for this overall. So remember, what is our function? We're dealing with sine, right? You have to know how the shape looks, right? So we start down here, we go up to its maximum point right here, we go back to its intercept, down to its minimum, and back to its intercept. And just as I said, as this side of the video says transformation, in the next video we're gonna be learning, right? This is the answer for this graph that we've just figured out. But for our next video, I'm gonna be teaching you guys how to reflect this graph over the y-axis, right? How to sort of create this reflection both on the